Hey guys, welcome back to Tim's Electronics Lab. I'm Tim, and today we're going to do a little experiment. Now, as some of you might already know, I started to work on a sensor kit for outside, and it includes a rain detection sensor. Now, it's a common problem that the sensor gets corroded after a while because of the DC voltage. All the electrons are attracted to the negative side, and the whole negative side just corrodes away. It will take a month or 2, 3 if you constantly apply voltage to it and leave it outdoors. So today I'm going to actually do a little experiment and hopefully discover how to enable non-corrosion or non-corrosive rain detection without switching the voltage over and over again, since it also requires you to switch and flip the output pins of the sensor. So we are going to do this experiment by soldering traces to a PCB, to two PCBs actually, connecting wires to the end, putting one in aluminum or in plastic foil with perforated with a micro perforation in it, so that the water should be able to still penetrate the thing, but not in huge amounts. And the one is just going to be completely open, and we're going to put it inside a cup of water, apply voltage to it, and see what the result will be. So first things first, we need to solder a trace, but that doesn't matter. So pick a jumper wire, pick two jumper wires actually, some solder and a PCB, prototyping PCB, and let's solder it to the PCB. Like that. Now we're just going to create one massive loop. So I will end here. Want these 4 pads fully covered in solder, and of course like that, being connected with each other, and like this. Prep for the big solder trace that's going to be here.
Like that. So that's one. That's two. Oh, almost.
So, alright, that's one. You know, massive short circuit, but that's what we want. We want to apply voltage to it, put it inside water and see what it does. Now I'm going to recreate this on a second prototyping board, and we're going to test them out. Nice. So that is done. Now oh wait, we're still going to wrap one in. This is the hot one, this is the cold one. We're going to wrap the cold one in the perforated, micro perforated tin foil, or not tin foil, just plastic foil. It's way less micro perforated than I hoped it was be. But so let's cut a piece. I'll actually just lay down the board in it and wrap it a few times, and then cut it like that. Nice. Alright. And wrap it. So now wrap it up. And to test it, well, you might already have guessed it, we are going to put it inside some glasses with water and apply voltage to it with my lab bench to hopefully see, hopefully see what happens. So just fill it up until the blob is on the water, like that. It's really weird putting electronics inside water, I can already tell you that. But you know, we've got to make a video. So that's luckily I've got 2 channels on my power supply, and I will need them both, so that's good. Now this one is a little bit loose, and I don't like that. Alright, so remove my loop. Okay, so I'm going to set them at the same voltage, which will be around the maximum voltage my power supply can put out, which is around 30 volts. To make it as quick as possible. Like that. So this is basically electrolysis, what we are trying to do. I'm not sure if it will work with my trusty my trusty power supply. But we're going to find out really soon. I'm going to want everything exactly the same, so this one is going to be the positive, this one the negative. Now the idea is that we should start to see some bubbles. Let me zoom in. And then everything is supposed to be working. I need to fill them up more. Fill them up all the way, so you are able to hopefully see what's happening. It's a little more like that. Alright, cool. Turn on my power supply, ramp the voltage up to 25 volts. And limit the current, of course. Now, let's apply some voltage. Now, of course, the current is going to be limited. and I can already feel the wires heating up, and not not what I was expecting. Oh. Oh, it smells horrible. Shit. Yeah. Oh, I don't think we need to connect them. So let's remove the solder blob in the middle. Yes. That's what we needed to do. So now I'm going to manage this. This one needs to be unwrapped. First need to turn off the outputs. This one needs to be unwrapped. I think I'll just get some new tinfoil on it, because this isn't working anymore. Everything will be wet.
Well, it's still dry out here, so that's good, but I'm not sure if the sensor is able to pick up moisture right away, but hey, we're here with a reason. And the reason is to investigate what's going to happen, right? Oh, and what's supposed to happen. Make sure it's slightly wrapped around that. Now this works out great. I'll try this on the real sensor. I don't think this is going to work out, but I won't. Oh wait, shit. I didn't desolder it. Silly me. It's late. So yeah. Now I can rewrap it better this time. And firstly, I'll desolder it. Like that. No. What the hell? Oh, it's on the other side. I was like, where's the noise coming from? But it's the other side of the PCB. I'm going to take the non-wrap, which is this part, and wrap it around a couple of times. Actually, one time, like this. Okay, cool, great. So now, it should be fully wrapped. So let's insert them again and see what happens.
So let's turn on the power. You can immediately see all the bubbles over here in this one. And it's also drawing around 0.11 amps, 0.12. And this one's drawing none. Damn, that's going real quick. That's really going quick. It's dissolving like hell. So guys, the result is noticeable, if you may call it like that. Yeah, this one is the one without foil around it, and this one is the one with foil. And this one draws 0.11 amps, and this one draws 0 amps. So I'm just going to leave this because I want it to be completely Oh, you can already see some things building up on the positive side. Eh, feels really dirty. Woo! Sparks! Damn! That scared the hell out of me. You know, my power supply is at 25 volts, so huh? It just went so hot that it actually started to melt the solder. Alright. Oh, it's hot. It's really hot and dirty. And it feels really, not good. But hey, let's insert it back. I'm going to wash my hands. So I washed my hands and let the thing continue. Now there is something building up in here. A little bit of water, but that's okay, I think, because there's no direct water contact and surface, and I think that this will last way longer than obviously that one. So it's really nasty. Look at the gump that's been built up. I'm not sure what this is, but it doesn't look like this one. I can't imagine this is good for electronics. But hey, let's continue, since we're here to learn. It's all sticking and gluing up right now. So lots of electronic particles have came off this thing, and not so lots of this one. Well, it's a little white, and that indicates, yeah, of course, the whiteness that's going on right here. But this is much less white. And I think if we regulate the power, so don't let it be always on, of the rain detection sensor, I think it will be alright. So let's hope, because this, yeah, is it hot? No, I think it's a little warmer than the other one, but stir it around a bit. You can actually hear it. Until I of course short it out. Whoosh. Oh. I just removed the top of this should work. Why isn't this working? Yeah, there you go. Just boiling some things. Oh, the wires are getting hot. Now there's a little coating around it now, I think. Oh, that's really bad. Ooh. I don't know what that is, but this doesn't look good and healthy at all. I think it's some kind of carbon buildup. It's... oh yeah, that's hot. I wasn't expecting it to get hot, but it went. So, hey. Damn, it shocked me. Oh, I shouldn't play with electricity that much. So, I think that this wraps it up for this video. You know, it's clearly not very good to just put bare electronics inside water or outside in the normal earth environment, just like rain and such. So you should protect them in any way. And I think that this foil is a very good way. So this test is over exaggerated, of course. Both things have been running at around 25 volts, which is yeah, that's of course not going to happen with my rain detection sensor. That's going to run at well, 5 volts at max. So this test is just to see what's happening if you yeah, actually what is corrosion of metals and why the electronics are going to stop working when they're wet. So this is the reason why the whole circuit board gets gummed up with all kinds of shit. And yeah, you know, it doesn't work, because they're, well, clean is another word, but all the things that they are getting gummed up with is things that came from PCB traces. So PCB traces are no more on the circuit board, but they're just floating around in the breeze, in the water at the circuit board, and that's not what you want if you are a lab designer. So, I just thought that it was warm. So this wraps it up for this video. A nice little pun. This wraps it up. Never mind. This wraps it up for this video. I hope you found this interesting. If you do, please share this video with your friends. And if you don't, please let me know why, because then I'll try to improve it. And I see you in the next video. Bye. Thanks for watching this video. I hope you've enjoyed it. If you did, please leave a like. Make sure to leave a comment down below. You can also share this video with your friends if you think they will like it too. See you next time.